Okay, hello everyone. So first I would like to thank you for your time to be part of this presentation today. And also at the same time I'm very honored that I had the chance to present this topic in front of you. And I think that it will be a very interesting topic that I'm going to present today. So my topic is cloud protection, the fight of machine learning against the DDoS and ITC attacks. But before starting, I would like to give you an introduction about myself for those who don't know me. So I am Rrezearta Thaqi, and currently I'm a teaching assistant at the University of Pristina, the Faculty of Electrical and Computer Engineering. And at the same time, I'm a first-year PhD degree student at the same faculty, and also a DevOps engineer for almost 3 years. So that's also the reason why I have oriented my topic into the cloud, related to my experience that I had until now. And also, through this topic, we will not see not only the fight that has machine learning against the DDoS and MTC attacks, but we will see that how does machine learning enhance the detection processes of these types of attacks and also the others. So, I haven't prepared you what I'm going to talk about today, but we're going to see along the way, so it could be maybe more interesting for you. I'm going to start a bit with an introduction, and then we're going to dive in into the world of cloud computing and how machine learning has its approaches through their algorithms to improve this process of detection of these attacks. So, as all we know, cloud computing is one of the most popular technologies nowadays. So, if we see before some years ago and until now, there are a lot of change that has occurred in the IT companies. I have showed here in these figures the changes that have been done from 2019 to 2025. You can see that there has been a comparison between traditional or on-premise and cloud computing that is going to happen now. So if we can see, cloud computing has a total revenue comparing to traditional one, having a very great growth in revenue and also in usage. Now we can say, why is this? So we know what are the advantages of cloud computing, including its scalability and also its safety and many other things that improves many processes in the IT industry. But also, apart from the advantages that cloud computing has, it also has its disadvantages that we're going to see right now. That is cloud security. So why especially cloud security? Because machine learning until now has made different solutions, not only for detecting threats or vulnerabilities in cloud, but also for other different environments. But I'm going to orient my topic towards cloud security was also the main purpose of this topic. So the main attacks that are happening now in the cloud are DDoS and MITC. That's also the reason that I have chosen these two to see how is the process of detection, so to remediate them and to avoid these problems in the future. But if you can see, through some research that I've made, I have seen some of the most recent vulnerabilities or attacks that are happening in cloud. As you can see, there are security incidents during runtime, unauthorized access, misconfigurations, major vulnerabilities that have not been remediated, and also a failed audit. Now we can see the part of unauthorized access that is for 33%. This is a part of MITC. Because MITC is an attack where a user can get different resources in cloud without having the need to be authorized in that environment. And also, on the other hand, there is DDoS, that is in the group of the first one, security incidents during runtime, that is for 34%. Now, the main purpose of DDoS is to overload the network traffic. That's sending a lot of packets, a lot of requests until it blocks the website or that environment that is operating. And also we have data loss, data corruption, and also many others, but these are some of the more popular ones in cloud computing. And now many researchers have been done of what approach to take in order to detect this kind of vulnerabilities, because they're being day by day growing one by one. So we can see that is a big interest in using machine learning for attacks detection, and now we can see why. I have summarized here some of the papers that have used machine learning in detecting different attacks in cloud, but not those that I'm going to talk about later. So the process detection of cloud attacks is still a known topic. As we saw earlier, cloud security is a very sensitive topic and it needs to be improved. So there is where machine learning helps this way. So through the researches, there are some of different machine learning algorithms that have been used through years. So most of the more popular one is ILSTM through automated training, and then also there were different approaches using statistical methods combination and algorithms machine learning, achieving from this an accuracy of 99.26% and also a detection rate of this kind of attack of 100%. And also using a hybrid algorithm for DDoS and MitC, which I have been trying to do. Now through the slides, we're going to see what approach I have provided to detect these two vulnerabilities in cloud using machine learning and also the algorithms using to do that. And also what I was based to do this approach is the network packets characteristics analysis. And here is a figure of how is that done. So first, the network traffic is analyzed, and then for each packet, there are different fields extracted from that, and this is the phase where we collect the data that is going to be trained and also to do the prediction by machine learning using the data that we have generated. But for more details, we're going to see in the next slides. So I kind of mentioned what DDoS and MitC are. So here we are going to see with figures what they actually do in the cloud environment. So the first picture, there is an example of how DDoS affects in cloud environments. So the previous slide, I said that the main purpose is to overload the traffic that is currently operating in the cloud environment. So in this figure, we have a legitimate user that currently can be us, that is trying to operate through the internet, and the other part is the victim or the second person that is trying to communicate with us. So in the middle, we have the internet. We can suppose that we have a cloud environment that is operating that part. And there we can see 3 machines that are controlled by attacker. Now here, in the middle of communication between 2 users, we can see different attacks with 3 machines in this example. Now maybe you saw the first part of the conference today, how DDoS actually work with real scenarios as we saw. So that is with 3 different machines from different IP addresses that are trying to attack or to overload the traffic through this network between the 2 users. And this is how DDoS is done. And at the moment, the other part is the victim and can get the data that was sent from the legitimate user because of the hackers that were in the middle of the internet. And on the other hand, we have the MitC attack or the unauthorized access. So we can suppose to have this hero cloud environment and also a person that tries to upload a file there with authorized access, that is, should be. And on the other hand, we have a hacker in this case that tries to upload a file there and also to download from there without being authorized. And in this case, we have a cycle that's created for the MitC attack. We can also see that when the hacker gets or uploads something in the cloud, the main user that has an access, maybe it doesn't know at all, and there could be many consequences. So after this, we can see what machine learning algorithms I have chosen to be analyzed in this case. So there are 4 machine learning algorithms that I have chosen. There are decision trees, or vector machine, naive bias, and key nearest neighbors. All of these are machine learning algorithms that are from the part of supervised learning. And now why I have chosen 4 algorithms. We will see on the slides later. After analyzing each of these algorithms, we can see that the algorithm that has the most higher accuracy will be used for prediction. Now we can see that all of these, some of those are fast, some of those maybe doesn't operate a good and big quantity of data, some of those are easy and fast, some of those are easy to be applied, but this is related also to the size of the data set that can be used and also for what operation they're going to be used to do the prediction. So the case study that we're going to analyze now, as we saw from the title, is about a cloud environment. So the first step includes creating a cloud environment. In this case, I have shown a simple architecture of the cloud environment that is going to be analyzed. Now it's an EC2 instance that is created in the AWS, and it has full access to the internet. And also there is a web application hosted. To be this analyzed is more complicated than it seems. So to see how does it work. And after that, I'm going to show you how I did some simulation tests of the DDoS and MitC in that environment. And now we get to the most important steps of this case study. That is packets analysis, data collection, models training, then finding the best algorithm, and last but not least, that is the main part of this, is doing the prediction to see if these attacks will happen in the future or not. So these are the configuration of this EC2 instance that I have created. As I said, it's accessible from outside. It has a web application hosted, and now we're going to see how it reacts. So here are 2 screenshots. The first screenshot tells of how the DDoS attack is conducted in this case. So there are some examples that we can do the DDoS attack, including specifying the number of attacks that we want to use, or the number of packets that we want to send towards the cloud environment. But now, as you can see, I have made an endless loop. So through this code, we do the DDoS attack, sending a lot of packets until we block completely the website that is hosted on the EC2 instance in AWS. And then after sending all those requests in this case, you can see that after the try part, there are some GET requests that are being sent through that cloud environment. And until we see that the website is blocked, then this process is finished, and so on. We can continue with the process of detection. And at the other side, I have shown you a part of code to simulate the MitC attack. We already saw that what is the main purpose. So we have the first method of uploading a file without having an authorization, and the second one is downloading the file from the cloud environment. And also the synchronize method that synchronizes the files in order so the user cannot detect that there is any change in its cloud environment. And here we have a screenshot after the DDoS attack is conducted, and we can see that the site can be reached. And after this part, we continue to analyze all those parameters of those packets that we are interested in. So as you can see, I have chosen some of the most important characteristics that I want to analyze in this case for each packet. So we have the duration, source IP, destination IP, protocol, SYN bits, acknowledgement bit, FIM bit, and also the packet size, packet per second, sequence number, and is attack. Now, the variable is attack. In this case, can have the value 0 or 1. Now, it only relies if that packet that is going through that network connection is supposed to be an attack or not. So in this part of the code is the process of how each of those parameters are being extracted. So this part at the end you can see at the code. In order to know if we should give this attack the value 0 or 1, we do this analyzing this PPS, or in this case that is packets per second. And if it is above 1,000, then the sequence number is analyzed. And based on that, its attack can have the values 0 or 1. And this is an example of how a data set is after extracting all those data that we're interested in. So this data set can be up to 100,000 rows or more, but this is only a part of the data set of how it can be looked. As you can see at this attack part, some of the rows has the value 0, and some of the rows have the value 1. Now, we can, if we can analyze the part of the PPS, we can see that those rows where PPS or packets per second are 900, for example, or 577, we can see that the attack is 0. Now, in that case, that process where that packet was being sent over that network, it wasn't considered to be vulnerable, and thus is not an attack. It's not an attack. And we see the other values that are above 1,000. We have 1,200. We have 4,000. We can see that the value of this attack is 1, and thus we can know that that packet was intended to cause an attack in that cloud environment. After generating this data set, then we define the models of each algorithm that is going to be analyzed, the 4 ones that we showed earlier. And then for each of those models that are being created after using those 4 algorithms, each of the models are evaluated. And then we extract the accuracy score. So in order to find that which is the most accurate algorithm in this case, we see the accuracy score. And in this case, in this execution, decision tree was the most accurate algorithm, and that was going to be used for the prediction. Here we have a screenshot where we find the model with the highest accuracy. That is labeled as the mass model. And after that, the result of prediction is being shown in that application that is hosted. In that case, we have that a DDoS or MITC attack is likely to occur on this IP address in the near future. That tells that it's vulnerable also in the future. Now, as I said, decision trees was the most accurate algorithm in this case, and it showed a percent of accuracy of 100. So after getting the results of the simulation of these attacks and the detection of them, I also did some tests, including the variables of timestamp, page ID, number of requests, number of errors, duration, bytes sent, data, and is attack. Here you can give different values, different number of requests, and then you can see through that model if your cloud environment is vulnerable also from this attack or not. So it can highly be used also for different projects if you want to be using this. Here's a summary of the results that I've gained through this experimentation, if can I say. So as you can see, the first part is when I conducted or simulated those attacks through those scripts that we have shown before on the slides. So we can, if you can see, there are different examples of number of threads that are 100, 1,000, 10,000, 500, and 2,500. And for different amount of threshold, that is the number of PPS or packets per second. For example, in the first case, we have if the PPS is greater than 1,000, that we already had an example when the data was generated. The other part is when the PPS is greater than 50, greater than 100, greater than 50, and also greater than 10. And also the duration of how much time did it take to make the simulation of attacks and how much was the time of the detection of those attacks. And also the prediction that it tells that if that cloud environment is vulnerable or not. We can see that for some of the cases we have true for almost 100%, but this doesn't tell the accuracy score of the algorithm that was being used, because I said before there's 100. Now we can see that is 0.975, for example. But this is how much are the chances so the environment can be vulnerable to attacks in the future. If we can see now the second table, in this case, I have used JMeter to to do or to simulate those attacks in this case. And I have compared with those that I did through the scripts. And as you can see, there aren't much difference in the prediction score, but we can see some of them. For example, we see the false prediction of the first row from the two tables. We can see that the first one we have false of 0.1712. Now we have 0.191, but this also can be related to the duration of the attack or the number of requests that has been done. But in order to be more precisely, I have chosen the same number of threads also when I did the test in JMeter, the threshold, and also the duration, so the results can be more positive or more related to each other. And now I'm going to give you some takeaways or some conclusions from this analysis. Now, through this study, we can also say that machine learning is a great method and plays a vital role to increase the accuracy of detecting different attacks, not only in cloud environments, but also in other environments. And it also can adapt to evolving attack techniques. Now we can see at the end what are the possible improvements in this case. We saw what DDoS attacks are, also MITC attacks, and how they can be achieved, how they can be simulated, and how they can be detected. But remember, there are also different approaches apart from machine learning, but machine learning has shown a very great role in detecting this kind of attacks, so it's highly recommended to use that. So some of the possible improvements that are in this case can be the four that I have highlighted here. So, for example, improve feature selection. So if you saw that part that I have extracted data based on some features that I were interested in, so maybe in the future we can also see other features that have a great impact maybe in the future in that process. Or maybe to use hybrid approaches. As I said, we can combine 2 or 3 machine learning algorithms to improve that accuracy score in order to have better results. The behavior analysis and also threat intelligence. Now in my PhD studies, I'm working in this direction of threat intelligence. So with threat intelligence, we can maybe achieve a more accurate score. And thus we can see that how it differs with machine learning techniques when we use to collect data with extracting from the packet, and also different improvements, but these are some of the most important ones that can be used to be in the future. So thank you very much for your attention. If you have any questions or comments, you're welcome.
Thank you, Rrezearta. Do we have any question? Yep.
Hi, my question is, can we use something similar to kind of build early warning system, like, for example, number of connection from those IPs?
I'm not hearing you very well. Can you repeat the question?
Can we use something similar or the same model to use kind of early warning system, for example, with the same logic?
Mm-hmm. Yeah, as I said, the solution can be integrated of whatever you want to do. It's very easy to be integrated and automated at the same time, so you can use it for different purposes. You can not also detect the DDoS or MITC, but also you can get different vulnerabilities or attacks that you want to consider in your environment, so it can be easily integrated.
Also, can you elaborate a bit more the link between threat intelligence? How can we utilize threat intel in this case?
Okay, the threat intelligence part.
Mm-hmm.
Mm-hmm. Okay. So we saw at the previous slides how those data were generated. Now through threat intelligence, we can have more data analyzing now also using that data for different alarms. So it can help us to know before when an attack is being done in that environment, and also to use different data sets, also analyzing maybe 2 or 3 environments at the same time. So that was the logic of using threat intelligence in the future.
Thank you.
Great, thank you. Any other question? Yeah.
Thank you. For these machine learning models to make reliable predictions and accurate predictions, they obviously need a lot of data to trade on. Now, like smaller businesses or organizations or whatever, they might have a lot less network traffic going through their cloud environment, so a lot less data to work with. Could they benefit from these models, or is the data too little?
Well, it's right as you said, because as much data as we have is better. We have a great accuracy. But it's not very worth it for small companies, because if they don't have a large amount of data, maybe they won't get an accurate result or something, and that maybe it won't be as much as accurate as it could be for a greater company, for example.
Great. Thank you. Any other question? Thank you, Rrezearta. That was a very great presentation.
Thank you very much.